Hello everyone, my name is Vineet Chen and today I will be presenting on the topic known as flame photometer, an essential analytical instrument for metal ion detection, particularly alkali and alkaline earth metals. So let's dive into the content of this presentation. Here is an overview of the presentation. We will start with an introduction to the flame photometer, move on to its principle of operations, the components, calibration, application, advantages, limitations, and finally the maintenance tips. So, introduction. The flame photometer is widely used analytical instrument that detects and measures the concentration of metal ions, especially alkali and alkaline earth metals. It works based on the principle of atomic emission, making it particularly useful for analyzing metal ions like sodium, potassium, lithium, calcium, and barium. So, coming to the principle of operations. Flame photometry works through a step-by-step process. First, the sample is introduced via nebulizer, forming a mist mixed with fuel gas. The high temperature flame vaporizes the sample, and the metal atoms emit light characteristic to their wavelength. This emitted light is captured by photodetector, converted into electrical signal, and displayed as the concentration of the metal ions. So this is step-by-step process of flame photometry. Sample introduction. Nebulizer aspirates sample forming a mist mixed with fuel gas in burner. Atomization and excitation. Flame heat vaporizes solvent, leaving metal atoms which emit light in characteristic color, for example, sodium as yellow, potassium as violet. Emission of light. Excited atoms return to ground state, releasing light at element-specific wavelengths. Detection and measurement. Photodetector captures light intensity, converts it to an electrical signal, and displays concentration based on calibration. So this here is a schematic diagram of photometer. Components of flame photometer. Nebulizer. It converts the liquid sample into a mist for consistent flow into the flame. Burner. It mixes the sample with fuel and air, generating a high temperature flame for atom excitation. Optical filter system. It isolates specific wavelengths for accurate detection. Detector. It converts light intensity into an electrical signal. And readout or display. Display the metal ion concentration, often digitally. Calibration and standardization process. Calibration is crucial for accurate readings. It involves preparing standard solution of known concentrations, measuring their light intensity, and plotting a calibration curve. Unknown sample concentrations are determined by matching their intensity to the curve. Regular recalibration ensures reliability, especially after instrument downtime. Now, coming to the applications. Clinical, for measuring sodium and potassium in blood or urine, aiding in health diagnostics. Agriculture, soil and plant tissue analysis to optimize fertilization and crop management. Environmental, assessing metal ions in water for contamination control. Industrial quality control, ensuring consistent metal ions levels in product like food and pharmaceuticals. Coming on to the advantages. It is high sensitive for alkali and alkaline earth metals. Simplicity in operation requiring minimal sample preparation. Rapid and cost-efficient analysis making it ideal for routine testing. However, it does have some limitations. It's limited to alkali and alkaline earth metals, excluding transition metals. It is susceptible to interference from other elements or ions. It is less precise compared to advanced techniques like AAS or ICP-OES, making it more suitable for semi-quantitative analysis. Coming on to the maintenance. Clean the burner and nebulizer to prevent clogs. Check flame stability and recalibrate frequently. Maintain the optics by cleaning filters and aligning components regularly. Thank you.